Okay, so in the last lesson we looked at the properties for quadrilaterals. Now we're going to talk about the properties for a specific quadrilateral, the parallelogram. So if we have a parallelogram, and by the way, this is a parallelogram here on the right, and we'll just call that parallelogram A, B, C, D. Because it's a parallelogram, we already do know what that means based on the definition. We know that line segment AB is parallel to line segment CD, and line segment CB is parallel to line segment AD. We also know from our earlier work this semester that the opposite sides are not only parallel, but they're congruent as well. So AB is congruent to CD, and AD is congruent to CB. Okay, and that'll always be true if the quadrilateral is a parallelogram. Now keep in mind, if it's just a quadrilateral, if it's not specifically a parallelogram, or remember that means a rectangle or a square, then this would not be true. Okay, now another fact. So let's actually, before we look at the next fact, let's write out what we know. So we marked the diagram, but what that means is, if this is a parallelogram, then I can say that segment AB is congruent to segment CD, and segment AD is congruent to segment CB. Okay? Now, not only are the opposite sides congruent, but the opposite angles are congruent. So when we're talking about opposite angles of a parallelogram, what we're talking about here would be angle A and angle C. They're opposite from one another. They're complete on the opposite side of the parallelogram. So angle A is congruent to angle C. Also, we know that D and B are congruent. So angle D is congruent to angle B. Okay, because both of those are because of opposite angles are congruent. Okay, the next thing we know is that any pair of consecutive angles are supplementary. Okay, so let's make sure we understand what that means. Consecutive, remember, means that they're in a row, they're right beside one another. So that means that I could, in this diagram, pick out any pair of angles that are right beside one another or adjacent to one another, and they are supplementary. So for example, angle D and angle A. Angle D and angle A are adjacent or consecutive, and because of that, and because this is a parallelogram, angle A and angle D are supplementary. Similarly, angle D and angle C. And C and B. And B and A. Okay, so all those are going to be supplementary. Now, before we move on to the last piece of information about parallelogram properties, I want to talk about why that is that the consecutive angles are supplementary. So in order to do that, I'm going to take a look here at, I'm going to just extend this line, and I'm going to extend this line. Those are my parallel lines, okay? And we'll look at the other set of parallel lines in a moment. But those are my parallel lines, and they're cut by this transversal. Okay, so if you remember when we talked about parallel lines cut by a transversal, we had all these different angles that were formed. Well, in this particular parallelogram, if I'm looking at these two parallel lines, the ones that I marked, and the transversal, the line CB is a transversal, then I'm noticing that the two angles that are right alongside of line segment CB, those are consecutive angles. Okay, so we just said that they're supplementary. Well, here's why. Because in relationship to the parallel lines, those two angles, I'm talking about right here and right here, those two angles are same side interior. They're on the same side of the transversal, and they're on the inside of the parallel lines. If you recall from earlier in the semester, we said that same side interior angles are supplementary when the lines are parallel, cut by a transversal, which is what we have here. So that's why angle C and angle B are supplementary, because they're same side interior angles. Okay? Now, if I take a look at the other set of parallel lines, and actually I think I'll change colors here just to make it a little bit easier to see. So if I'm looking at this set, the purple set of parallel lines cut by this transversal, okay, we still have angles A and B. Angles A and B are on the same side of that transversal line AB that I just drew, and they're on the inside of the two parallel lines. So they're same side interior angles, which means they're supplementary. So angles A and B are supplementary. Okay, and that would work all the way around the parallelogram, which is why any pair of consecutive angles, they're supplementary to one another. Okay, the last piece of information for a parallelogram. Keep in mind all these have to do with the quadrilateral being a parallelogram. Okay, so the last one is that the diagonals bisect each other. Now let's look at the second diagram. I drew a second one because I knew the first one would have a lot of markings on it. So the diagonals bisect each other. Let's think about that term. We learned it earlier in the semester. Bisect means to cut in half or to go right through the midpoint. So if the diagonals bisect each other, our diagonals here are segment DB and segment AC. If they bisect each other, then that means that that point E is the midpoint of each of those diagonals. Okay, so E is the midpoint of segment DB and AC. Okay, so if it's the midpoint, we know that that means it goes right through the middle and it divides the segments into two congruent segments, which means that segment DE and segment EB are congruent. So DE is congruent to segment EB, and AE, segment AE is congruent to segment EC. Okay, and we know that because this is a parallelogram, and in parallelograms the diagonals bisect each other. Okay, so let's use this information to do a couple example problems. So this first example, this is a parallelogram, we're told that. Okay, so all those things we just talked about are true here. So we're supposed to find x, y, and z. Okay, well the first thing I'm seeing is x. So I'm just going to go in order here. So I see x is a consecutive angle with angle 52. Well, we said a moment ago consecutive angles are supplementary because they're same side interior angles. So I'm going to subtract 180 minus the 52 degrees. And when I do that, I'm getting 28 degrees. And so that means that x, the measure of angle P, which is x, is 28 degrees. Okay. Now, if I have that filled in as 28, I can get y either by using the same fact again, that same side interior angles are supplementary. So I would get y by subtracting 28 from 180, or because angle L and angle A are opposite angles in a parallelogram, they're congruent. So I know that angle y is 52 degrees. Measure of angle y is 52 degrees. Actually, that's angle A, which we're calling y. Okay. Lastly, I'm supposed to figure out what z is. Well, z has to do with the side length. This is a parallelogram, and we know that opposite sides are congruent. So that means 8 inches is going to be the same as PL, which is 9z minus 37. So 8 is equal to 9z minus 37. So I'm going to solve for z. So I'm going to add 37 to each side. So 9z equals 37 plus 8 is 45. Dividing each side by 9 gives me z is equal to 5. And we're talking about units here. These are inches. So that's z. Z is equal to 5 inches. Y was 52 degrees and x was 28 degrees. Okay, let's look at another example. So, second example, we have this parallelogram, and we know PR, that's the entire length of the one diagonal, and we're supposed to find PS. Well, we know that when the quadrilateral is a parallelogram, which this is, the diagonals bisect each other. So if I know the whole length of one of the diagonals, I also know that this point S is the midpoint. So if it's the midpoint, that means segment PS and segment SR are congruent. So if I know PR, which is the whole entire thing, I'm just going to take PR and divide it in half so that I know what each of the pieces, each of the halves is equal to. Well, 15 halves is equal to 7.5, and these are centimeters. So that's the length of PS, which is also the same as SR. I was supposed to find PS, though. Okay. Last example. So now we have the same parallelogram, but we know AS and we know SL. Well, we know that AS and SL are congruent to each other because this is a parallelogram and the diagonals bisect each other. So I'm going to set AS is length, 2x minus 6, equal to SL's length, which is 5x minus 8. I don't know what's going on here. Excuse these extra marks. So 2x minus 6 is equal to 5x minus 18. So let's solve that for x. I'm going to subtract 2x from each side. So that gives me 3x. I'm going to add 18 to each side. So 18 plus negative 6 is 12. So I have 3x equals 12. Dividing each side by 3, I'm getting x equals 4. And these are centimeters. It didn't ask me to find x, though. It asked me to find AL. All right, so I don't have AL in either of these expressions, but I do know that they're both going to be equal to each other, and that one of their lengths doubled will give me the length of the whole entire diagonal. So I'll just substitute x in for one of these expressions. It doesn't matter which one, and then I'll double it. So 2 times 4 minus 6. 8 minus 6 is 2. 2 centimeters is the length of both AS and also SL. And I could put 4 in for x in this expression. I would still get 2. So if I have 2 and 2 again, 2 doubled is 4, so the length of AL is 2 doubled, which is 4 centimeters. Okay. So next you should try pages 9 and 10, the odd numbered problems, to get some practice on some similar problems.